Okay, so now we want to try to go in the other direction. We're given the graph of a rational function, and we're trying to use that to write an equation for a rational function whose graph would look like this. So first of all, I've got some prompts to identify some key features of the graph, starting with the let me be sure I have my drawing tool ready, with the x-intercept. So the graph is crossing the x-axis in only one point here at -2, it looks like. So the x-intercept is at -2. I'm thinking about what I want to do with that. I suppose I'm just going to fill in this information right now. The y-intercept, so the graph is crossing the y-axis here at 6. And I'm not writing coordinates this time, I'm just writing the value. Okay, vertical asymptote. So there appears to be a vertical asymptote right here, which is where x is equal to -1. So there's a vertical asymptote at x equals -1. And a horizontal asymptote. So here, again, I mean, we're having to sort of approximate, but it looks like there's a horizontal asymptote at y equals 3. Okay, so now we want to write the equation for the function with this graph. And so to do that, you have to think about where each of these features comes from in terms of the actual equation of the graph. I'm going to use black here. So I'm going to build the function right here. Starting with x-intercept. So x-intercept comes from the zeros of the numerator, right? These are the zeros of the numerator. So if -2 is the only zero of the numerator, that means the corresponding factor, x plus 2, should be a factor in the numerator. -2 is a zero of the numerator, then x plus 2 is a factor of the numerator. Vertical asymptotes come from setting the denominator equal to 0. Remember, that's when you simplify the function first and then you set the denominator equal to 0 in order to find vertical asymptotes. So in other words, this tells us that -1 is a zero of the denominator, which means x minus -1, which is x plus 1, is a factor of the denominator. So x plus 1 is a factor of the denominator. All right, I'm going to move on to horizontal asymptote. So when you get horizontal asymptote equals a non-zero number like 3, if you think about when that happens when you do the ratio of the leading coefficients. Because remember, there's 3 options when you're talking about non-vertical asymptotes. You can have a higher degree on top. So if it's top heavy, then you have a slant asymptote, not a horizontal asymptote. Sorry, it's erasing over there. If it's bottom heavy, then you have a horizontal asymptote at y equals 0. And if it's balanced, then that's when you do the ratio of the leading coefficients and you can get a non-zero number. So we're looking at a balanced function here if you have a horizontal asymptote at y equals 3. And the ratio of your leading coefficients should be 3/1 to get this y equals 3. So I'm going to go over here and make the leading coefficients 3/1. All right, so now we've got the horizontal asymptote at y equals 3, vertical asymptote at x equals -1, x-intercept at -2. We've got all of those things. We need to check whether we have the correct y-intercept. So remember, y-intercept came from plugging 0 into the function. So let's check. I'm going to go up here where there's more room. If we plug 0 into the function that we have so far, right here, this would be 3 times 0 plus 2 over, I'm plugging in 0. I was going to write 3. 0 plus 1. So this will be 3 times 2, 6 over 1. So this one just checks out. I mean, it looks like this function now does everything we need. So this is going to be your answer. If you want, you could write that. I mean, you wouldn't really need the 1 out here. So you could write this in the factored form if you want, or not in the factored form. This is probably the way I would express it. If we had a y-intercept of like 12, then that would just mean we need to, well, it's hard to know what we would need to adjust. I mean, there probably something else would be different. So I'll just say this, that for when you're finding the y-intercept, or I would do that last in these problems. And what you should do is plug in 0, double check that you get the correct y-intercept. If you don't, then I would say double check that your other features are correct. And if they are, then just look at what else you can do to the equation to make your output equal to 6 or whatever the y-intercept is supposed to be. I think I'm going to go ahead and continue in this example. Well, I'm going to pause first so I can erase. There's one more graph. We're trying to, again, work backwards. We want to look for the features of this graph and try to write the equation of a function that has those features. So first what I want to do is analyze the features of the graph. So that's what I have the prompts for here, for the intercepts and the asymptotes. So x-intercepts in this graph, there are a few actually. So it looks like we have an x-intercept here, and that's it, right? So this looks like, let's see, here's -1, 2, 3, 4, 5. Yeah, so it looks like there is an x-intercept at -3, and then another x-intercept at +2. Okay. Or let me put -3 and 2. So those aren't coordinates, those are individual x values. Y-intercept, well, it looks like this graph never crosses the y-axis. In fact, it looks like the y-axis is a vertical asymptote, which the y-axis is the line x equals 0. So I'm going to go ahead and put that in. It looks like x equals 0 is a vertical asymptote in this graph. So for y-intercept, I would say none. We have a vertical asymptote at x equals 0. And while we're talking about vertical asymptotes, it looks like there's another one here at x equals 5. Okay, and then last thing, horizontal asymptote. So again, we're going to have to kind of approximate looking at this graph, but I would say it looks like it's right here, which would be at -1. Y equals -1. So I'm going to put that for the horizontal asymptote. Okay, so now that we've written down those features, now we want to go back and think about where they come from so we can write the equation of the graph. So first of all, x-intercept, that comes from the zeros of the numerator. So if -3 is a 0 of the numerator, then x plus 3 is a factor of the numerator. And if 2 is a 0 of the numerator, then x minus 2 is a factor of the numerator. Okay, so we've got our factors of the numerator done. Vertical asymptotes come from zeros of the denominator. So we can do the same kind of thing with the denominator here using the vertical asymptotes. So if 0 is a 0 of the denominator, then x minus 0, which is just x, is a factor of the denominator. And if 5 is a 0 of the denominator, then x minus 5 is a factor of the denominator. So these factors came from the vertical asymptotes. These factors came from the x-intercepts. And as far as, like, if you're wondering, okay, how am I supposed to know which is which? This summary sheet that I gave you guys here, this is what you should refer to. So x-intercept is when the numerator equals 0. Vertical asymptotes when the denominator equals 0. That's after you cancel any common factors. But these graphs that we're looking at right now don't have holes, so we can assume we don't have those common factors. Okay, so we've dealt with the intercepts, or x-intercept anyway. We've dealt with the vertical asymptote. Okay, how about horizontal asymptote? So horizontal asymptote has to do with the degree of the numerator and the denominator. If you have a non-zero horizontal asymptote, like y equals a number like this, like I was saying earlier, that's when you're in the scenario where you have a balanced rational expression, meaning same degree in the numerator and the denominator, which we do have already in the equation because we have degree 2 on top, degree 2 on the bottom. 2 factors on top, 2 factors on the bottom. So this is balanced the way we want it to be. But leading coefficients, ratio of the leading coefficients needs to be -1. So I'm going to make that -1 over 1. Now the ratio of our leading coefficients is -1. So now we have the correct horizontal asymptote. Y-intercept, none. Notice that the equation I have right now fits that bill because if x equals 0, then you're dividing by 0, so the function's undefined. So this graph will not have a y-intercept. There's no point on this graph when x equals 0. And so at this point, yeah, we could give this as our final answer. I mean, it's fine to leave it in the factored form. In fact, I think that's kind of preferred to have the numerator and denominator factored. So I would probably write my final answer like this.